In this video, I'll construct a function of the form y equals ae to the rx. It's an exponential function, and it's going to go through two given points. Now we always have the option of using exponential regression for this kind of thing, and that can be done either with a web-based app or on the TI-84 calculator. But let's go over how to do this algebraically with 2 points without using regression at all. This example says construct an exponential function of the form a e to the rx that goes through the points 1, 2 and 3, 6. Now to take the algebra approach of solving this, we want to first plug in an x of 1 into the formula. So we'll get y of 1 equals ae to the r times 1. Over here we'll simultaneously do the same thing but with the other coordinate. Our whole goal here is going to be to identify the correct constant value of a and r that makes this exponential function go through those 2 points. Now it says plug in the corresponding y values that go along with those x's. So we're going to want 2 equals ae to the r times 1, which will just be r. Over here we'll have 6 equals ae to the 3r. Like it says, we now have 2 equations and 2 unknowns. And a system of equations like that is solvable. So a substitution can be performed here. We want to divide to get a alone. The reason why this is helpful is if this expression is equal to a and this expression is also equal to a, then they must be equal to each other. Now I can cross multiply and rearrange the terms. And we want to solve for the only variable left, which is r. We eliminated the a variable. I'll use the rules of exponents here. 3r minus r makes e to the 2r. And now when we have e to a variable here, we need to get rid of that e by using an ln. So we need to ln both sides of the equation. Natural log and e are inverse operations. They cancel each other out, so we would be left with 2r equals ln 3. Therefore, r equals ln 3 over 2. Now that we have r, we can plug back into one of the original equations to find a. I'll go with this equation, which would make it quite easy. It's already solved for a. We have to plug in our value of r. Okay, so this is approximately 1.1574. Alright, so it says in order to retain the exact form of the initial y, we can use log properties to simplify. So yo is actually going to be y of 0, which in this case is actually going to be a. The reason why is when x is 0, e to the rx becomes 1, and then we're just left with y equals a. So let's see if we can rewrite this into an exact form. We can take apart the ln 3 over 2 and separate them in this way. The reason why is when we have an exponent divided by another exponent, that would be the same as ln 3 times a half. Whenever we're multiplying exponents in that way, we would be raising an exponent to another exponent. So we're allowed to separate them like this. When we do, the e and the ln cancel, making this 2 over radical 3. And if we rationalize, we'll get 2 radical 3 over 3. So the exact form of the best fit function would then be y equals a e to the rx, which will be 2 radical 3 over 3 e to the ln 3 over 2 x.